Hello friends, this video is continuation of decision tree. In previous video, this is part 2 of decision tree. In previous video, we saw about what is decision tree and why how to select feature that we need to split, and how to check whether the node is pure or impure. We already see about the concept of entropy. Today we are going to see about how can we check whether the node is pure or impure by using Jenny impurity. The formula for Jenny impurity is 1 minus summation of I1 to n and probability square. This is the formula for Jenny impurity. Let's take this example. Okay, let's take this example and we can apply Jenny impurity for this tree. Okay, Gi equal to 1 minus summation of 1 to n means for this I represent number of features. Here we having only two outcomes, yes or no, in output. Okay, so we need to use only two conditions. Let's find Gi for C1. 1 minus, that is totally probability of S is 1 by 6, sorry 3 by 6 whole square, and plus summation, and the probability of no is 3 by 6 whole square. When we computing this we can write this formula in this form also, because we having yes or no. Like we can apply this formula as 1 minus p plus whole square plus p minus whole square. Like this we can write this formula for this 3. After applying this formula, we can get this, and then after computing you will get 1 minus 1 by 2 whole square plus 1 by 2 square. Then we will get 0.5 for an entropy. The output will be ranges between 0 to 1. Like that, for an Jenny impurity, the value will be range between 0 to 0.5. Okay, when for entropy output is 0, then it means it was a pure node or pure split. When we are get 0 for Jenny impurity, the same like entropy, it is a pure split. Okay, here we are getting 0.5 for Gen impurity, the maximum value is 0.5. Here also we are getting 0.5. So it is a proper 100% impure split. Yes, it was a correct answer, because here the S is 3 and no is 3. So it is an impure split. Let's apply this formula for C2. After applying C2, Gen impurity for C2 is 1 minus, there are totally 3 yes and 0 no's. That means 3 by 3 whole square plus 0 by 3 whole square equal to, we will get answer as 1 minus 1 square plus 0 square is equal to 1 minus 1. We get 0. That means this C2 is pure split. So here for C1 we will getting a value of entropy 1 and Gen impurity is 0.5. Then it was an impure split, so we need to split this node further. But for C2 we getting entropy and Gen is 0 as 0, so that we not need to split C2 further. The C2 is a leaf node, we can stop splitting here. Like this we want to split further, and we have to compute entropy and Gen. Like this we want to continue until we getting 0 for all other nodes. Okay, we see how to check whether the node is in a form of pure split or an impure split. We can compute it by using Gen impurity, or other we can use entropy. We have doubt what is different between entropy and Gen impurity. We have that doubt. We can see this graphically in a 2D graph. This is probability of plus and minus, and here is h of 1. This is h1, and the value of here is 0. When you are plotting h1, when it is when the entropy is maximum value of 1, when we graphically, the dot is this form like this bell structure curve for an Gen impurity. The max value is 0.5. that will come here. Here is where you will get Gen impurity. This is the difference between Gen impurity and the entropy. Impurity. For example, we having probability as for -1, for probability minus and probability plus as let's is consider is 2 probability 0.525, for probability plus, probability minus as 0.75. then the entropy will be between 0.75 and Gen has a value of 0.25. like this it will be come. Okay. And when we use, we have a question, we can find if a node is pure or impure by using entropy or Gini index, but which one is best and which one we can use for an small data set. We can use entropy, and for an large data we can use Gini impurity, because the why we should use entropy for small data, why we did not use for large data, because here we in entropy we having a function of log. So log to compute a log for an value, it is taking process when compared to summation. So that mostly we will use Gini impurity to compute or whenever we checking nodes are pure or impure, we can use Gini. Okay, let's see about how we can select a feature to split. How do we select feature to split? We already see in previous video, by using information gain, we can find best feature to split with. Okay, let's take an example. We having a data set which have feature 1, feature 2 and feature 3, and the output we can start splitting by f1, f2 and f3, or we can start with f2, here is f1 and here is f3, or we can use f3 also, but which one is best when compared to by comparing these three form to compute we can use information gain. The gain, how to compute a gain? To compute gain, we have a formula h of s minus summation of v belongs to value and sv by s by image of sv. Okay, this is the formula for gain, to compute a gain. Okay, this h of s is represent entropy of root node and this represent entropy of current node. Okay, okay, let's compute. Okay, let's take an example. We are having a f1 and c1 and c2. having C1 and C2 and we having okay, and C1 having a value of 6s and 2n, and this having a 3y and 3n. For this feature we having feature 1 we having 9s and 5n. For this totally 14 conditions are there, for this 8 conditions are there, and for C2 there are 6 conditions are there. To find gen, first we need to find h of s. For h of s we need to find h of s is entropy of root node. This was the root node, so we need to find entropy of this node, and the formula is p minus p plus log 2 p plus minus p minus log 2 p minus the p probability of positive is here totally 9s, and total outcomes are 14 for f1, so it was 9 by 14. The probability of p s is 9 by 14, log 2 9 by 14, probability of plus is 9 by 14, like probability of minus is 5 by 14, log 5 by 14. Then we computing this, we will get approximately 0.94, and we need to find for h of sv. For subnodes we want to compute entropy for h1 hc1. When we computing, we will get this is c1. When we are computing c1 entropy, we will get minus 6 by 8 log 6 by 8 minus 2 by 8 log 2 and 2 by 8. We will get 0.81, and when you are computing entropy for C2, we will get 1. After computing these values, let's substitute in this formula. Jain formula is h of s is 0.94, and h of c1 is 0.81, and h of c2 is 1. Gain formula is h of s minus summation of value v of value and sv by s h of sv is the formula, and the h of s, h of s is we already computed, that was 0.94 minus, and sv by s is we have to first compute for, there are totally 2 child nodes c1 and c2. First we want to apply these for c1 and C1. For C1, we have totally, for C1 we have totally totally 8 outcomes and the root node having 14 outcomes. So here we want to put 8 by 14 and h of SV, h of C1 is 0.81. Here we have computed this, and then we need to find for C2. For C2 there are 6 outcomes are there, and for that C2 root node 14 outcomes are there. So 6 by 14 and into C2 entropy is 1. Here we have computed this, and after applying this we will get gain is 0.49 for gain of S of F1. We find the gain for the first node, for this F1 node. The F1 is a root node and F2 and F3 is a child node. For this for this tree structure, we have get gain is 0.049. Okay. We directly let's assume for this tree like structure, we just assume we get that 0.051. okay. For whenever we choosing F1 as a root node and we getting that 0.4049, whenever we choosing F2 as a root node we getting 0.051. When comparing these two values, F2 as a I gain, having I gain, so that this F2 is the best feature to use as a root node when compared to F1. So F2 is selected as root node because it has I gain of I, so that it was the best root node to use F2 as a feature. Okay, like this the tree, for every feature the tree will form and by using this tree like structure we will give input and going to the root node we will find whether the for an input data what will the output. By after creating this tree like structure, this is called decision tree because addition in each node addition will be made, whether the feature is going to split this side or this side or this side or this side, like this, that data will be splitted. After we will make a decision and for that input data, like this only decision tree will be work. I think you all understand this. By this this is the base concept. Decision tree is the base concept for random forest. In random forest we will use more number of decision tree. We will create more number of decision tree and depending upon the all outcome from the different decision tree, the which having a more probability output, we will conclude that output as final output. So this is the basic mathematical things behind the decision tree. Thank you.